Howdy, 7th grade. Today we are going to talk about exponential growth and exponential decay, which is also something you've been learning a little bit about in the JA Junior Achievement stuff, which is really awesome. So getting to look at exponential growth on the math side of thing now should make maybe us get a little bit more appreciation for it. So this is kind of going to be how interest works, although this is going to be a much bigger form of interest. So I want you to think real quick if you had two options. And option one is that you get paid $1,000 a day for your chores, which I know is a lot of money. So you get $1,000 a day for a month. So by the end of the month, you'll have like $30,000. That'll be awesome. And option two is going to be that you get 1 cent the first day, 2 cents the second, and we're going to keep doubling it. So that'd be 4 cents the third, and 8 the fourth, and so on. So I want you to think for a second, which would you rather have? Option one, where you get $1,000 every day for a month, or option two, where you get 1 cent, then 2 cents, then 4, then 8 for a month. So we already said at the end of a month, we would end up with $1,000 a day for each of the 30 days of the month. That would be $30,000 for option one. Option two, you would not end up with $30,000. Instead, you would end up with, I believe it would be $10,737,418. That's option two. So, I know that it seems kind of ridiculous that, if you take the 1 cent over the $1,000, you'll end up with more money. But that's kind of how this growth and decay thing works, is that if we keep multiplying things over and over again, we're going to end up with a truly ridiculous amount at the end. So let's look at a couple more of these. Let's look at maybe a more realistic problem, like an interest problem, and see what that looks like. So let's say that I have $100 in the bank, and I have a really great savings account that pays me 2% back every year. So I get 2% interest every year. So that's 2% growth, which means it should be going up by 2%, which means it would be after 1 year, I would still have my original $100, but now I would have my 2%, or 0.02, times $100 in there as well. So 2% of 100 is $2, hopefully we know that. And then plus the $100 in there that we had to begin with is going to end up with $102. So after 1 year, I'd have $102. After 2 years, I'm going to once again start with my 102, and I'm going to add my interest rate times what is in there, except this time I don't have $100 in there, I have $102 in there. So it's going to grow a little bit faster. What that means is that my 2% now is going to bump me all the way up to having, that's the same as saying 102 plus, that would be 4.02, which is going to equal, now all of a sudden I have $106.02. I appreciate the 2 cents, but it doesn't really help me that much. I did that math wrong. Give me just 1 second. I switched my 4 and my 2. It happens sometimes. So this should be the 2 and the 4, 204. 102 plus 2 is 4. There we go. So I would end up with $104.04 after 2 years. And if we keep doing this for a while, it'll keep growing and growing and growing, and it will be very, very useful. But of course, there's always going to be a easier way of doing this. So let me show you the easier way. Is that if we have a % interest rate, then what we can do is we can just multiply it by itself. So our growth right there, if we notice, was 1.02 was our growth. So that's our growth. What that means is that we can find how much it's total going to grow, growth after a number of years, instead of multiplying by 1.02, if I want to do it after 2 years, I'm going to multiply it by 1.02 to the power of the numbers. So after 2 years, it would be 102 squared. After 3 years, it would be 102 to the third power, and it just keeps on going. So if I wanted to, instead of keeping on adding like that, I could just do it, raise it to a power, and that would work, and that would make my life a little bit easier. Decay is the exact same thing, except backwards. So decay is growth in reverse. What that means, it's like it halves every year, or it quarters every year. So a lot of times when we look into this, a real life application is radiocarbon dating, which is how we figure out how old dinosaurs are, is that they have something in them, and the amount of that they have halves every year. So you can end up figuring out how much is left. So if we start off with, let's say, 250 pounds of fruit. That's a lot of fruit. And I'm going to say that half of it rots every week. Then I can say that after 1 week, I will have 125 pounds left, because I have to half it, because half of it rots. After 2 weeks, I'll have 62.5 left. And I can just keep halving it, because half of 125 is 62.5. After 3 weeks, I'd half it again, and I would end up with 31.25 left. So anytime that we're multiplying by something and getting bigger every time, that is an exponential growth. Anytime we are multiplying by something and getting smaller, so multiplying by a half or just anything less than 1, then that is exponential decay. So that was basically just a vocab lesson for today. We wanted to remember what exponential growth and exponential decay are. Both of them are when you repeatedly multiply by the same thing. Growth is when it gets bigger, and decay is when it gets smaller. I will see y'all tomorrow. Have a great day.